Hi everyone. Hope everyone had a great lunch and is having a great time at Eat Dubai. My name is Nico. I'm the founder and CEO of Tenderize, and the presentation just went away. Oh, it was just on the screensaver. Okay, let's go. So I'm going to give a little bit of a technical talk today. I actually prepared this because I thought there was going to be a hackathon, and I was informed the hackathon was yesterday and before the event. But nonetheless, let's still have the talk, and we'll talk about building scalable protocols with clones. Like I said, my name is Nico from Tenderize, founder and CEO. Before Tenderize, I worked for LivePeer for 3 years, building their smart contracts and protocol. So this will not be a deep dive into proxies. If you want to learn more about proxy contracts, I suggest you go to the DEF CON archive and check out Alice in Proxyland from Alejandro. It's a really great talk on proxies. And the credit for the ID that we're talking about today, it's not my invention. The credit for it goes to Zephram from SudoSwap and Wigawak from Hard at Deploy. So why do we use proxies in smart contract development? 2 reasons: upgradability and creating multiple instances of the same code. If we drop upgradability and we just want multiple instances, we basically get clones of the same contract. And why do we need clones at Tenderize? Why do we need multiple instances of the same contract? We're a liquid staking protocol, and what we do is basically build a ERC20 token and vault for every validator on the network. So it's the same piece of code deployed over and over again. For example, in the case of the Graph network, there's like 300 indexers. So that would mean we would have to deploy the vault and the token 300 times, which is not really that cost efficient. You can also think of something like Uniswap, whereby each liquidity pool is the same piece of code, just with different tokens and parameters that it handles. So let's see how this actually would work without a proxy first. And we're just going to set an immutable variable A on a contract. So this talk will have a bit of code in it. I was told this was not a good idea, so I hope it's like readable. So if we just have a regular contract, my contract, and we want to set an immutable variable, we just do it in the constructor when we deploy the contract. And the variable A will then be filled in the runtime bytecode of the contract. Now, if we want to switch to a proxy, this becomes really problematic. You can't use a constant or an immutable with the proxy. So variable A will be saved in storage instead. And because we're using a proxy, we also have to match the storage between the bottom contract and the top contract. Otherwise, you can get storage collisions, which could lead to very bad things happening to your contract. So here the top one is the implementation, and the bottom one is the contract, and users would call the bottom one to execute the logic of the top one, but the storage would be written to the one below. But if we now want to access the parameter A, and this can be, for example, the token that we use in a liquidity pool, or for our case, the validator that a specific vault will stake to, then this becomes a very expensive storage read each time we want to access this. So as to summarize, with a proxy, you have no immutables. You use storage operations, which are very expensive. And you need to make sure that the storage layout of your proxy contract matches the implementation. And that has led to many exploits already over the course of the last few years, not matching the storage layout correctly. So how does this happen if we use clones with what we call immutables? You basically have a contract, and it has a function to get the value of A, but you see there is no declaration for an immutable variable. There is no declaration for a storage slot for A. Yet, if we call getA, we will be returned the value that it's supposed to be. And if you see in the middle right about, it actually loads something from the call data. How does this work? So when we deploy a clone, we will actually deploy it with some arguments attached to it. Here you can see in the first green part that we create our arguments. In this case, we want to set the value of A to 1337. And we then deploy the clone with those arguments. And if we then call getA on our contract, we will get the value returned. But like we said, it was never initially declared here in the contract. So what kind of sorcery is this, and how does this actually work? So let me explain a little bit of the magic to you. This is, on the left, you see basically the library of clones that was written by Zefram and Wigawag. And the essence of what it does is the first part of the bytes memory immutables, the arguments that we supply, they are actually appended to the bytecode of the proxy contract you're creating or the clone you are creating. And then with every call you make to your implementation, what you have added to the bytecode at the end is appended to the call data of the function you call. So you can access this piece of call data with the arguments from your implementation contract. And what it achieves is basically you get the same characteristics of using immutables or constants, but then with proxy contracts. The only downside is that the amount of arguments you can append to the bytecode is limited in length, and the entire length of the appended bytecode would be added to the call data, but luckily call data is pretty cheap, so it's not really that big of a problem. And as a practical example, how do we use it in Tenderize? We have 4 different parameters that we want to get cheaply, and that is the asset that is being staked, the validator being staked to, and then 2 internal modules that we use. And none of these functions actually use storage slots, so it makes it really cost efficient for each instance of the contract to fetch the parameters it needs. And it solves a big problem of otherwise having to use initialize functions in your proxy contracts or your clones, which is not really nice for UX. And if you don't do that correctly, can also lead to severe exploits. So I'm keeping it short today, so thank you for listening to this technical talk. Thanks for Zefram and Wigawag for coming up with this. If you want to know more about Tenderize, you can visit our website, or we have a booth all the way in the back to the right. Feel free to hop by. We still have a few t-shirts and shorts left, not many. But yeah, you're welcome to pick them up. Thank you, everyone.